Hi, this is Anthony. In this episode of Battery Experts with Anton Parr, we will discuss the viscosity and other rheological properties of battery slurries. Rheological properties of battery slurries will have a direct influence on the coating process, the structure of the coated layer, and eventually the electrochemical performance of the battery. Battery slurries have shear thinning behavior during mixing, meaning their viscosity decreases with the increasing shear rates. This flow behavior is determined by measuring the flow index of the slurry. A flow index that is smaller than 1 indicates that the slurry is shear thinning. To determine the flow index, either a viscometer or a rheometer can be used. For viscometers, there are absolute systems and relative systems. All absolute systems and some relative systems are standardized following specific norms. These standards for absolute systems apply to viscometers as well as rheometers. For measurements, one can use either disposable cups or standard reusable cups. Additionally, the measurements can be performed with or without a temperature control device, but it is recommended to stabilize the temperature, typically at 25 degrees Celsius, in order to get consistent results. After booting up, and once the digitally monitored leveling status of the instrument and temperature control device have been adjusted, load a pre-existing method or create a new one by setting a start and end point of the shear rate. Set a number of data points depending on the precision you would want to achieve. Set the temperature and runtime. Attach the spindle, which is automatically recognized by the viscometer, and start the analysis. In real-time measurement, the live graph displayed will look like this. Once the analysis is done, go to Measured Data to see the flow index and the flow behavior graph. In the generated report, all the details and the parameters are recorded, which is a great tool for traceability and historical data. Now, in order to assess slurry behavior during mixing, pumping, and coating, it is important to measure their viscosity and other viscoelastic properties with a rheometer. Viscosity measurements are straightforward. Measuring viscosity with a rheometer at various shear rates usually takes just about a couple of minutes, depending on the shear rate range. After installing the correct measuring system, which in this case is a plate, the zero position called zero gap is determined. And after putting the slurry sample on the plate, one can use the option of a solvent trap in order to slow down solvent evaporation during measurement. With the start of the measurement, the upper plate is lowered and the sample is pressed. Remove the excess slurry by trimming with a spatula. In the method template, set the desired shear rate values, in this case 0.01 to 1000 reciprocal seconds. Choose the desired number of data points, set the plate temperature if necessary, and start. Another important property of slurries is the sedimentation stability. This property is assessed by a well-known method called frequency sweep, performed as an oscillatory measurement. A slurry is deemed stable when the storage modulus G' is higher than the loss modulus G'. High frequencies enable the evaluation of a sample's short-term behavior, while low frequencies simulate the behavior of the sample over long time at rest. If the value of G' remains higher than that of G', the slurry is stable. However, once G' becomes larger than G', that would be considered the crossover point below which the slurry sediments. In the software, open the template Frequency Sweep, type in the shear strain value depending on the sample type, set the angular frequency range, for example from 100 rad per second to 0.1 rad per second, and start. So, understanding and accurately measuring the various rheological properties of battery slurries is very important during this crucial step in the process of battery manufacturing.